Next up, we are going to look at linear inequalities really quickly. They are similar to linear equations, so you don't have to worry too much about it. Okay, so linear inequalities. So they're just linear equations, but the equal sign is replaced with an inequality. So we were working with something like y equals 3x plus 7, running with the same example. An inequality would just mean we're replacing this equal sign with something like this. Do note that we can also do something where we pair the equality with the inequality, and we will still call this a linear inequality. So this is a linear function, and then the ones on the bottom is what we're working with right now. This is a linear inequality. Okay. All right. Now we have a graphical representation. You really don't have much to there's not a lot of SAT problems that will ask about linear inequalities, but just to know it, this is what a linear inequality would look like. This is the same example from before. So then this is y equals 3x plus 7. That's this line, the dotted line here. So the inequality shows that the y value is always less than that line, right? The y value, the red, everything shaded is below the line. That means that y is going to be less than 3x plus 7. And because it's dotted, that means that it's not going to be equal to 3x plus 7. If it was dotted, it would be a solid line. So that means that this is going to be y is strictly less than 3x plus 7. So then we have that entire shaded area covered as possible values for y given some value of x. Now moving on. Right, so here we go. An important difference, just as discussed before. This solid line means that your y value can actually equal that line, whereas this dotted line means your y value can't be that line. So then if you were to describe this using linear inequalities, you would have something like y is going to be less than and or equal to 3x plus 7. And then in this case, it would be strictly less than, or just y less than 3x plus 7. So then this will actually change answers to questions if you're given something like, what can y be given x, right? Y can only be a certain range below a certain point with y less than. But if it's less than or equal to, then y can actually take some value that 3x plus 7 defines. Say, for example, x is equal to 1. Then, in the left-hand side case, you would have y is less than or equal to 3 times 1 is 3 plus 7 is 10. So y is less than or equal to 10. So can y be equal to 10? Well, of course, y can be equal to 10 because 10 is less than or equal to 10. But can y equal 10 on the right-hand side? Well, let's see if it makes sense. Y equals 10. Let's assume y equals 10. Then y equals 10 is less than 3 plus 7, which is equal to 10. 10 is less than 10 doesn't make any sense because 10 is equal to 10. So no, y cannot equal 10. Y must be less than 10, which is exactly what you will get if you plug in x equals 1 into this equation on the right-hand side here. So that sums up everything you need to know for linear inequalities and equations. Make sure you look at the textbook and do some practice problems. See you in the next chapter.